Hey YouTube, welcome to this episode where I'm going to walk you through what has been regarded as one of the trickiest A-level exam questions that's ever been asked. So what we're going to look at is the common misconceptions that students have been making. I'm going to walk you through what students should have done. And also at the end, I'm going to show you the examiner's report to really demonstrate why this question was difficult and what percentage of students actually even attempted this. So it's quite strange because usually when it comes to the hardest exam questions, the mark distribution is a lot higher. Here it's only 2 marks and 1 mark. So students obviously looked at this and wondered, why is it at the end of the paper? This was question 8 in one of the old spec papers. So let's get right to it. So it says, given that y equals arc cos x, x is between -1 and 1, y is between 0 and pi, express arc sine x in terms of y. So what did students first do? Now, a lot of students, in terms of express arc sine x in terms of y. So, what did most students end up doing? Those that did attempt this, they would have written down y equals arc cos x. Now, they recognize that arc cos represents the inverse of cos. So, we want to rewrite this statement. So, we want to rewrite it by taking cosine of both sides, because cos will cancel arc cos, and we're left with x equals cos y. Now, I'd say a decent amount of students did manage to write this, but then from here is where a lot of mistakes started happening. So what did some of the more able students do from here? They started using the triangle. So they thought, okay, well, because we want arc sine, we want to rewrite cos in terms of sine. And the way they did that is they drew a triangle, and we're doing cosine of y. The angle here is y, and we're just left with x. We know cosine means the adjacent over the hypotenuse, so they rewrote x as x over 1. So the adjacent side would be x, and the hypotenuse 1. Then they did Pythagoras and said that the opposite side would be 1 minus x squared. So then they said, okay, well, sine y then would be the opposite, root 1 minus x squared divided by 1. But then the problem comes is they did inverse sine and they're left with y. So they haven't actually rearranged for arc sine x. They found arc sine root 1 minus x squared. So that's a problem. And also, this question's worth 2 marks. The amount of work we've just done here is worth way more than 2 marks. So what should students have done instead? Going back to x equals cos y, that would have given you 1 mark. The next steps are actually not that difficult if you remember what the transformations of sine and cosine are relative to each other. So if we were to look at a right angled triangle and you have y, cos y, yes, is the adjacent side is x and the hypotenuse is 1. And what we want to do is we want to rewrite x over 1 using a different angle, this one. If that's y, then this angle here, if it was in degrees, would be 90 minus y, or in radians would be pi over 2 minus y. Now, how else could we represent x over 1? Well, we could have said sine of pi over 2 minus y is also x over 1. Well, if sine of pi over 2 minus y is x, and cos of y is x, it must mean that sine of pi over 2 minus y is the same as cos of y. Now, these are trig identities that you do need to remember. My students know it as the acute angle transformations. So whenever I mention acute angle transformations, they know exactly what I'm talking about. So cos of y would be sine of pi over 2 minus y. Similarly, sine of y would be the exact same as cos of pi over 2 minus y. So what we actually needed to do, this is basically just the explanations, is all we needed to do was we needed to rewrite cos of y as sine of pi over 2 minus y equals x. Because then when you do inverse sine of both sides, you're left with pi over 2 minus y is arc sine of x. Then it's done. And now you can see why it was worth 2 marks. So the first mark comes from saying cos of y is x. The second mark, basically then you get to the answer anyway, is by rewriting cos of y as sine of pi over 2 minus y, and then you're left with your answer. So 2 marks, hardly any students manage to answer this, but it's actually really simple. So remember, the acute angle transformations, the rules are, if you have cos of x, that's the same as sine. Now it depends, it doesn't matter if you're doing in degrees or radians. I'm going to do in radians, pi over 2 minus x, and sine of x is cos of pi over 2 minus x. Please remember these, they will definitely help you out. Then for part 2, you'll see why it's worth 1 mark. Evaluate arc cos x plus arc sine x. Give your answer in terms of pi. Well, we just worked out that arc sine x is pi over 2 minus y. Arc cos x was just y, so we're left with y plus pi over 2 minus y. The y's cancel, we're left with pi over 2. And that's it. You can see why that's worth 1 mark. Hey guys, I hope you enjoyed my video. If you're new here and you want more maths content, then please consider subscribing. If you're learning something, then hit that like button. Comment down below to let me know what you want to learn next. I hope you enjoy the rest of the video. Now let's take a look at the examiner's report and see exactly what they said. If you're interested in seeing the actual full report, you can check the PDF down below. I've just linked it down there. Now what did they say? They said part 2 was rarely attempted. In part 2A, because this was actually part of a bigger question. The first part A, was done reasonably well. It was this one right at the end of the paper which wasn't done well. So part 2, part A, some managed to obtain x equals cos y, which obtained the first mark, but few gave either the acceptable answers pi over 2 minus y or arc sine of cos y. They didn't give the statistics on that, but then they said fewer than 10% of the candidates obtained a correct answer for part 2b, which was the y plus pi over 2 minus y. Now, based on that information, the part 2 bi was definitely much harder than part 2, because I'll tell you what some cheeky students could have done. If you get your calculator up, remember we were working out, they said state what arc cos x plus arc sine x is. If you go in your calculator and you do arc cos of just any random number, say 0.5, plus arc sine of the same random number, you get pi over 2. And if you just played around and you change 0.5 to 0.25, or make sure it's between minus 1 and 1, you always get pi over 2. So students could have actually just typed in that and just written pi over 2, they would have got the mark. So the real difficulty in this question is the first part that I did over with the pi over 2 minus y. So if less than 10% got the last part correct, then way less than 10% would have got that arc sine x question correct. So this has been regarded as one of the toughest questions that have ever been asked in Trig, based on the amount of students that managed to get it right. Now, they haven't actually asked this question since 2007. This question here was 2007. It was a C3 paper. It was question 8, and they haven't asked it since. So examiners are notorious for repeating questions every few years. They haven't asked this again, and this is why I love to teach my students this question. So guys, stay tuned. I will be uploading more papers or trickier past paper questions. And if you learned something, please hit the like button and subscribe for more maths content. I'll see you guys in my next episodes. Peace.